3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Velocity now 1,200 feet per second. Discovery downrange 3 nautical miles.
Humanity will always strive for innovation. It is in us to explore, learn, and grow. Launched on April 24, 1990, the Hubble telescope is a revolutionary machine that represented the dawn of a new frontier in space exploration for all of mankind. It forever changed our understanding of the universe and our place in it. Stephen Hawley, a mission specialist who worked on the telescope, tells his students that great things don't just happen. They are the product of a vision, advocacy for the vision.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Teamwork, leadership, technical skill, and persistence in the face of setbacks.
Fire in the spacecraft.
This certainly rang true for the Hubble telescope.
When we opened hatch in space, we were opening back on the Earth a era in the history of man.
We have ignition and we have liftoff.
The late 20th century was a groundbreaking time full of technological innovation. The rise of the internet meant that individuals across the world could be connected on a level never before seen in human history. In the wake of the Cold War, innovation was all around us, in our tech, on our oceans, even as satellites floating around amongst the stars as we looked up at the night sky. This is where Hubble's journey begins.
1946. Lyman Spitzer first suggested the idea of a space-based telescope. The National Academy of Sciences revisited the idea almost 2 decades later. It started off as the Large Space Telescope, but was later renamed after Edwin Hubble, a pioneer of astronomy in the 1930s. The Hubble Space Telescope was built by the National Aeronautics and Space Administration, more commonly known as NASA, and many other agencies worldwide. Hubble was supposed to be in orbit by 1983, however, its launch was repeatedly delayed due to technical issues and the devastating Challenger spacecraft explosion. Finally, on April 24, 1990, the whole world applauded as the Hubble telescope was launched into space aboard the Space Shuttle Discovery. 12 years in the making, the telescope was expected to last about 15, having been worked on by thousands of engineers and scientists, with a production cost of over $1.5 billion in taxpayer dollars. Hubble's orbit lies around 330 nautical miles above the ground, 70 miles higher than any other shuttle had flown before. It was a bumpy ride, but the Hubble Space Telescope had finally reached its destination.
Yeah, we all had high hopes, and we knew that we were a small part of something that was probably going to be revolutionary.
Controlled by astronomers and NASA's Goddard Space Flight Center, the solar-powered Hubble telescope transmits data via radio back to the ground. At 43.5 feet long, 14 feet wide, and weighing almost 27,000 pounds back on Earth, it was an enormous piece of equipment. The mirrors are the essence of Hubble. The primary mirror is used to collect light and reflect it to the secondary mirror, which then reflects it through a small hole into the chamber where all the telescope's scientific instruments are held. The telescope has 2 cameras, which provide detailed views of nebulae and star clusters. It also has 2 spectrographs, machines used to analyze light. Using these instruments, astronomers can determine the composition of faraway stars and galaxies.
It has capabilities that are unlike any other telescope that we have in space right now. So in particular, its ultraviolet capabilities are unparalleled by anything.
Interestingly, the telescope sees the universe in only black and white. Scientists add color to the photos later to match and enhance what we would see with our eyes. The Hubble telescope can gaze over 7 times farther into space than some of the most powerful terrestrial observatories, going above and beyond the existing frontier.
But, like Robert Frost once said, nothing gold can stay. 2 months after the launch, Hubble's first images were released to the public. But there was a problem. The images appeared to be blurry.
I remember that there was a lot of concern by the government that we had, spent all this money to build this observatory, and the mirror was out of focus. It was permanently out of focus.
After that, the telescope's reputation was ruined and was the butt of numerous jokes. The next servicing mission wasn't scheduled until 1993. It was a long shot. The issue was spherical aberration. The mirror's angle was off by a measurement equivalent to just 1/50th the width of a human hair. Imagine that. The solution? Corrective Optics Space Telescope Axle Replacement, COSTAR. This device, made from 5,000 individual parts, essentially functioned as an eyeglass for Hubble. Due to its complexity, it required a team of 32 astronauts to go up and make the corrections mid-air. They trained for months using a variety of tactics to ensure their success, using model replicas of the Hubble, virtual reality, and other complex technologies, first used in the days of Apollo. Nothing could go wrong.
But as we've seen in many earlier shuttle flights, things don't always go exactly as planned.
December 1993. It was time to do the impossible. The Space Shuttle Endeavour carried the team into space, where they were to complete 5 spacewalks, and save the Hubble. When the moment came for the long-awaited mission that would determine Hubble's fate,
I know we're going to succeed at this, and we're going to turn the Hubble Space Telescope in all regards into the exciting scientific instrument that we expect it to be.
It went off without a hitch, clearing the way for several more repair missions in 1997, 1999, 2002, and 2009 to keep the telescope operational.
And just immediately, just the discoveries started pouring in.
After this outer space repair job, the telescope worked perfectly. It helped us discover the age and size of the universe, as well as the rate of its expansion, known as the Big Bang Theory. Additionally, we know that there are over 2 trillion galaxies in the universe, and our own contains upwards of 200 billion stars. Seeing as most scientists a few hundred years ago believed that there was only one galaxy, you can imagine how far we've come. But perhaps the most important discoveries made by Hubble originated from a project started in 1995 by the director of the Space Science Institute, Bob Williams. He proposed an experiment where, for 100 hours, Hubble stared at a seemingly blank patch of sky near the handle of the Big Dipper that was only about 1/30th as wide as the full moon, taking 342 exposures in total. Of course, he was met with skepticism right away, but like he says in an interview, anytime you want to understand something, it is helpful to know its past and how it has evolved and changed. Our attempt to understand how the universe has evolved is so important that it was worth going forward despite all the skeptics. As it turned out, nothing was actually teeming with more than 3,000 galaxies, some almost 12 billion years old. In this picture alone, almost every single spot, speck, smudge, and spiral is an entire galaxy. This image would soon come to be known as the Hubble Deep Field. Hubble has also helped us see how stars grow and change over the course of eons. Taking advantage of Einstein's theory of relativity, the telescope is actually able to look back in time to find dark matter, advance research into the possibility of alien worlds, and discover some of the most powerful explosions known in the universe.
And it's still doing this. I expect that within 10 years, we will have found life on another planet.
At the end of the day, the Hubble Space Telescope has made over 1.2 million astronomical observations in the visible, ultraviolet, and infrared parts of the electromagnetic spectrum. Astronomers using data from the telescope have used it to publish more than 15,000 scientific papers, making it one of the most productive science instruments ever built. Its observations can be seen in astronomy textbooks all over the world. Having been hailed as the greatest revolution in astronomy since Galileo invented the simple telescope hundreds of years ago, Hubble laid the groundwork for a whole new generation of space-based telescopes, including the recent James Webb Telescope, which works in unison with the Hubble to observe early galaxy formation. As John N. Bacall, American astronomer, says, the most important discoveries will provide answers to questions that we do not yet know how to ask, and will concern objects that we have not yet imagined. The Hubble telescope did this, and much more.
While the Hubble telescope, launched on April 24, 1990, was a revolutionary machine, its journey was not without its ups and downs, and it has certainly made up for its setbacks with groundbreaking contributions to science. After all, what is the purpose of exploration and discovery if we cannot learn more about ourselves along the way? For the next 27 years, as we indeed learn more, Hubble will be the name attached to nearly every stunning piece of the remote cosmos transported to Earth, representing the dawn of a new frontier in space exploration for all mankind.